We're used to a very specific cosmic blueprint. A massive star sits at the center, planets circle that star, and smaller moons circle those planets. It's an orderly, nested hierarchy. For as long as we've been looking at the sky, this three-step arrangement has been the foundational rule for how we think the solar system is supposed to work. But the deeper we look into the galaxy, the more we find systems that don't seem to care about our rules. One of those systems sits 72 light-years away from Earth. From a distance, it looks normal, but the data tells a different story. This is CD-35 2722. When astronomer Kevin Hoy first looked at the orbital mechanics here, he described the system as super weird. He wasn't just reacting to the distance or the brightness. He was looking at a gravitational structure that forces us to reconsider what a satellite is actually allowed to be. To understand why this system is so disruptive, we have to move far past the central star, which is a perfectly normal, stable anchor, and look at what's orbiting it. The first strange element we encounter is a brown dwarf locked in a steady orbit around that central star. Think of a brown dwarf as a boundary object. It has significantly more mass than a gas giant, but never gained enough weight to ignite. It exists in this middle ground, a failed star massive enough to act as a gravitational anchor. This massive body sweeps through the system, circling the primary star while exerting its own powerful pull on everything nearby. While brown dwarfs are relatively rare, their physics are well documented and understood by space science. Finding a brown dwarf here isn't the anomaly. The real shift in understanding comes from looking at the specific object tucked deep inside its orbit. As we step down to the final level of the hierarchy, we focus on the space immediately surrounding the brown dwarf. Hidden in that gravitational well, researchers detected a massive, mysterious body. This is Jupiter, the largest planet in our solar system. The object orbiting the brown dwarf is its equal in scale. We are looking at a body as large as our most massive planet. Here is where the mechanics get strange. Because this behemoth orbits a substellar body, which in turn orbits a star, it technically occupies the orbital slot of a moon. It's a massive contradiction. You have a Jupiter-sized world operating in a nested role. You can trace the gravity chain. The exomoon circles the brown dwarf, while the dwarf maintains its orbit around the star. It is this specific nested relationship, a Jupiter-sized body acting as a satellite to a failed star, that makes this the universe's first confirmed exomoon. Now that we've seen the architecture of CD-35 2722, the implications for astrophysics start to ripple outward. This single discovery is proof that our own solar system is a limited template. We can no longer assume that the rest of the galaxy follows our local rules. If a failed star can host a moon the size of Jupiter, then the physical possibilities for what a solar system can look like have just expanded. As we continue to search for exoplanets and the building blocks of life, we have to look for them in places we previously thought were impossible. We are moving past our old definitions. We're beginning to map a universe filled with these bizarre, nested architectures, and CD-35 2722 was just the first sign.